Assalamu alaikum. I'm Vivian Shwaikani again. I'll be explaining part 3 of chapter 5, strong acid and strong bases. In this part, you have only one objective to be covered, which is actually to distinguish between a strong acid and a weak acid, as well as to distinguish between a strong base and a weak base. As usual, you need to prepare the pencil, some papers, and your chemistry book or a copy of the exercises in it. Let's start by the first idea, which is about a strong acid or strong acids. A strong acid actually is any acid that ionizes or dissociates completely in water. It means at 100%. The equation of dissociation of a strong acid, you know it from the previous lesson, so not necessary to be repeated and to be explained. Now, this reaction occurs in one direction. It is a direct one. It means it is not reversible. And according to the stoichiometry of the reaction, if you have to compare the concentration of the H3O plus ions, it would be equal to the concentration of acid, to the initial concentration of acid, that is equal to Ca. What is Ca? Concentration of acid. A is a small letter used to say that of Ca. Why? Because we said that the acid is completely dissociated to give H3O plus and A minus. So no acid molecules are left at the end. Now, for a weak acid, it is not the case. Actually, a weak acid is an acid that doesn't ionize or doesn't dissociate completely in water. Look here, this is the equation of the dissociation of a weak acid. This is the acid, this is a water molecule, and always we will have H3O plus ion, that is hydronium ion, and A minus. But as you notice, here is the difference. So, the acid HA and both ions H3O plus and A minus will reach an equilibrium state. Why? Because the reaction of dissociation of the weak acid is reversible, as it's shown here. Here. Now, according to what you have studied in equilibrium lesson, the concentration of the ions of H3O plus ions here resulting from the dissociation of the acid must be less than that of the initial concentration of the acid, denoted by Ca, concentration of the acid. Now, for a strong base, for the dissociation of a strong acid, let's have this figure that will give us an idea about the molecular level, what is happening here. Here, for example, I have represented, or I have used 7 molecules of acid. Okay, 7 molecules of acid. Here, 7 definitely it's not a number that is real, is totally far from the reality. But you know, we are using just an example, regardless now the real number of the molecule that is behind this number, just to have an idea about the dissociation. So look here, each molecule is 1 unit. Now once put in water, as you can see, they dissociate. Upon dissociation, look, all molecules without any exception, here they are, it means the ions of each molecule are split apart in order to give the violet balls, which are the anion, and the hydrogen ions, H plus, that are here represented by the orange ball. So all molecules are dissociated into ions. While for a weak acid, look here. Also here, I have decided to use 13 molecules, for example, of undissociated molecules. It means initially. This is a weak acid. Once in water, those molecules will dissociate. But actually, look, in our example, I decided that only 3 molecules are dissociated. Look, this is one ball that is blue with one that is red, which corresponds to hydrogen, and this is to the anion, and this is the second one, and this is the third. So here are the ions resulted from the dissociated molecule, and here the other are the undissociated molecules. As you can notice, the number of undissociated molecules is greater than that of dissociated, and this is what happens in reality. What about now a strong base? For a strong base, as in an acid, is also a strong base. It means ionizes or dissociates completely in water, and you know well how to write the equation of dissociation of a strong base. Now, the reaction occurs in one direction. It means it is direct, it is not reversible. According to the stoichiometry of the reaction, also the concentration of the OH minus of hydroxide ions here resulting from the dissociation of the base has a concentration that is equal to the initial concentration of the base CB. B is for the base and C is the concentration. So here also no base molecules, BOH, are left at the end since all are dissociated into B plus and OH minus. What about a weak base? Here is a table that will show us the difference between a strong acid versus a weak acid. Here is a strong acid. As we said, it is totally dissociated in water. The equation here is complete. It means it's not reversible. If we have to consider the initial concentration of the acid, it is Ca, as we said. Here it would be 0. Now, pay attention that we will not talk about the concentration of water molecule here because water is a solvent. So its concentration is almost constant. So we don't have to consider it here. So the concentration at infinite, okay, it means at the end time, it's 0 because we said that no acid molecules will be left. All of them will dissociate. And here it will become Ca and Ca because the stoichiometric coefficient is 1 and 1 here. By the way, this 1 and 1 is true for monoacids. And I said in this year previously that we will deal only with monoacids. Maybe not maybe, necessarily in the university you will see other examples of acid. But in this year, in all examples, we will have the concentration Ca of the acid. It is equal to the concentration of H3O plus resulting because we will deal only with monoacids. Now the degree of dissociation, although alpha is not used in case of complete reaction, but it is equal to N dissociated over N0. Since N dissociated it's equal to N0, as you can see here, alpha is equal to 1. What does that mean according to what you have seen in equilibrium? It means 100% of the molecules, of the acid molecules, are dissociated. So we will return to the fact that it is totally dissociated in water. And the concentration of H3O plus, as we said here, is equal to Ca. So the pH that is equal to minus log H3O plus, we can written it here, it would be equal to minus log Ca because Ca is equal to the concentration of H3O plus. One more fact related to a strong acid, that upon dilution 10 times a solution of a strong acid, the pH increases strictly by 1 unit. Now what about a weak acid? It is partially dissociated in water. So as you can see here, it is a reversible reaction. Here we have to deal with this equation typically as what? An equilibrium. At equilibrium here, you notice that the concentration of HF will decrease, but it becomes Ca minus X. X is the number of molecules that is dissociated, or here the concentration. So the degree of dissociation alpha, according to the definition, it is like this. And we will divide by V since in the table we dealt with concentration and not with number of mole. So alpha will be equal X over Ca, and X is definitely less than Ca. So alpha will be less than 1. Okay, and the concentration of H3O plus resulted would be less than of Ca. So the pH is greater than minus log Ca. Here also, upon dilution 10 times, solution of a weak acid, the pH increases by less than 1 unit and not by exactly 1 unit as in a strong acid. Now what about a strong base versus a weak base? It's almost the same. A strong base is totally dissociated. This is the equation that is complete and direct. This is the concentration of the base at time 0 and at time infinite or final. No more base is left. And Na plus concentration is Cb and the OH minus Cb. So the concentration of OH minus is equal to Cb, which is the concentration of the base, and the formula that is pH equal 14 plus log to OH minus concentration could be written like this. We can replace OH minus concentration by Cb, and upon dilution, a strong base solution 10 times, the pH of the diluted solution decreases by 1 unit with respect to the initial solution. Now, what about a weak base? This is a weak base, for example. You're not responsible for this here, but we have to give you an idea to understand exactly what is the difference. Why are we talking actually about strong bases? So this is a weak base. It doesn't have a complete dissociation, so it is an equilibrium state here. And this is the quantity or the amount, the concentration of the species at equilibrium. So degree of dissociation alpha would be equal to X over, sorry, here it's Cb, not Ca, excuse me, that is less than 1. And the concentration of OH minus is less than Cb, and definitely the pH will be less than this relation. Finally, upon dilution 10 times, a solution of a weak base, the pH decreases by less than 1 unit. Here is the first application of our lesson. Before we start, I have just to give you one idea about hydrogen chloride. Here, I will not lose my time in reading the given. You will read it alone upon pausing the video, but pay attention. HCl, it is in reality called hydrogen chloride in chemistry. Look, it's a gas. At room temperature, HCl is a gas, and it is called hydrogen chloride. But HCl is a gas that is highly soluble in water. So once HCl will be in water, it dissolves, and the solution obtained would be called hydrochloric acid solution. What do I want to say here? That HCl is not hydrochloric acid unless it is in water, while HCl, it is simply a gas called hydrogen chloride when it is not in water. Once being in water, it would be called hydrochloric acid. So these are the first 3 questions required in this application. Do a pause or pause the video, do it, and then check your answers because the answers will be given in red. These are the answers. Again, here is the same application. I repeated the given for you to be easier to remember the given, and here also the required question. Also, I will ask you to pause the video in order to write them on a scratch paper and then to check out your answers. Here are the answers. Now here is another application. Also, you will pause the video and you will check your answer. Finally, here is the agenda. Read it, pause the video to read. Definitely these exercises will not be done at once, but it's okay. I have listed because they are related to the objective of this lesson. Thanks for watching. I will see you in another video. Thanks.